Good morning, all of you. So, as we know, at present we are discussing about free fall. What is a free fall motion, and what is the equations for free fall and all. So now, let us see. Once again, we'll quickly recall what is free fall and all, and who has been proved that mass is independent of acceleration when it is in free fall state. That is what we have been concluded in the last class. Is it yes, guys? So if we'll drop two bodies which is heavier and as well as smaller from a certain height, then both will reach the ground at the same time. Is it yes or no? So that is the experiment which has been proved by Mr. Galileo. So now let us come to free fall. So what do you mean by free fall? What do you mean? What do you mean understand by free fall? In the last class we have been discussing. What do you mean by the free fall? Anybody? Please respond. So free fall means
object falling towards the gravitational force of Earth.
it is falling towards to the earth under the which force? Under the only one
Gravitational force.
no other force should act, or else you can say under only the gravitational force, only the gravitational force of earth, then we can say it is called as what? Free fall, and that object is called as freely falling
body.
Yes, sir. Now you can observe, as we know, if we drop any two objects, for example, like lighter object and heavier object, which object will reach us first? Basically,
Lighter objects, sir.
Lighter
objects.
Because heavier objects will experience, say, less friction compared to the other objects. So that suppose if you drop elephant and rat, so who is having more mass, more in size?
Elephant.
It will experience less friction of air and etc., so that it should reach the ground first. After that, here speed not experiencing a friction. So now rat will come later. But Galileo from the leaning tower of Pisa, he has been from the Italy. He has been dropped two stones. One is heavier object, another one is what?
Smaller object.
He has been found that both the stones has been hit the ground at the same time or different time? Same time. So from that he has been concluded that what he has been concluded? The acceleration of an object falling freely towards to what, guys? Towards to what?
To the ground.
Towards the earth does not depend on the mass of the object. Is it sir, Nora? Tamil Selvan? That is what we have been concluded. So, in a free fall motion, mass is the independent factor. Is it yes or no? So, mass is not dependent. Acceleration of the body which is falling towards to the ground. So during free fall, you can see heavier objects as well as lighter objects, they will accelerate at the same rate or different rate. They will accelerate at the
Same rate.
What is the acceleration of gravity? Acceleration due to gravity of earth, how much that value? We have been found
9.8 meters per second square.
Means when the body is falling towards the ground, you observe at every second the velocity is increasing. How much time? 9.8
meter per second.
Velocity increasing 9.8 meter per second per each second. For how much second? For each second. That is what we can say. It is 9.8 meter per second square. Do you understand, guys? Uniform velocity will keep on increases. So that is why when the body is going to hit the ground, before hitting the ground, the velocity is maximum or minimum? The velocity is maximum. Do you understand, guys? Velocity is maximum. Because when the body is free fall, the velocity increases continuously. At what rate? Uniform rate. What rate? Uniform rate. What is that value? 9.8 meter per second square. acceleration will increases at the rate of 9.8 meter per second square. So that's what we can say. That is, here mass is independent of it. Both heavier object and lighter object, both what is happening? They will accelerate at the same rate. That is you have to remember. Is it okay, guys? Okay,
Yes,
guys. So heavier object and as well as lighter object, but on the ground while they are traveling, who will go faster? Lighter and heavier object, who will travel faster? Lighter object. Understand? Lighter object will travel faster and heavier object will go slower when on the surface of ground. But when it is in free fall, both will travel, both will accelerate at the same speed and both will reach the ground at the same time, because
Same time.
mass is independent. Understanding that?
Mass is
Independent of acceleration. So this acceleration due to gravity is not depends on any kind of mass, whatever the size of the body, either it is heavier object or lighter object, doesn't matter. So it is always accelerates at the same speed. Understand? So that it is understanding both the bodies will reaches the ground. But the explanation given by the Galileo, you can see, suppose if you drop the feather and the stone or coin, who will reaches the ground first? Feather and the coin?
Coil.
Because feather having a large surface area. Is it yes or no? But if you take the coin, if you take a feather, so FATHF, so feather if you take, guys observe very carefully. So feather if you take, so what is happening, guys? So it is having a large surface area. Is it yes or no? So feather is having a large surface area, so that what is happening? It is experiences a more air friction. So air is trying to push it away from the ground. Do you understand, guys? So air is exerting more pressure. That is what we should call as friction exerted by air. Air friction, also we can say drag. Understanding? So this drag force is making the feather to fly away from the ground, and it does not allow to settle down easily because large surface area, so that easily it can fly away by the air friction. But if we take the coin, what is happening in the coin? 5 rupees coin alone, if you take for example, what is happening? It is having less surface area. So less surface area means less drag. Understand, guys? Less force exerted by the air on this coin, so that the coin will reaches to the ground first. Understand, guys? Please respond me. That is the reason. But if we recreating the feather and the coin experiment by using, understanding, where the air was pumped out from the glass tube. Suppose if I'll take suppose I am in a vacuum stage, certain stage where complete air is pumped away. Do you understand, guys? Inside nothing is there. Is it okay, Ra? Inside nothing. Empty space. Vacuum. So now at this place, if I'll drop the feather, and as well as one coin, what is happening, guys? Both will reaches the ground at the same time. So why, guys, here? Why? Because no air is present. If no air is present here, means in the sense of what? As we know, so mass is the independent of acceleration in the case of free fall, so that both will reaches the ground at the same time. Do you understand, guys? How? If you are pumping out what? We are pumping the air from the container. Understanding? Glass piece of glass, so that glass tube, so that feather and hammer were then released from the top. Both will be in the absence of air. The resistance becomes zero. Both will fall down at the same rate. Understand, guys? Same rate. That is what you have to remember. So from this you have to conclude one thing: the acceleration produced in the freely falling bodies is same for all the bodies. Is it yes or no? Because not dependent on the mass, understanding, it does not depend on the mass of the body. So that is why I can say in freely falling case, suppose you will fall or I will fall or else any elephant will fall or else any aeroplane will fall, then everybody will accelerate at what speed? Everybody will accelerate at 9.8 meter per
meter per
second.
second.
0.8 meter per second, sir.
Because in freely falling case, acceleration is what? Acceleration does not depend on what, guys?
Masses.
Does not depend on mass of the body. Understand, Sai, Pradosh,
Sir.
Manish? Any
Sir,
doubt?
understood, sir.
That is the important thing. But when you are traveling in the road, acceleration and mass are, what is the relation? Inversely proportional to each other.
Inversely proportional.
When it is
Acceleration
on
is
the
inversely
surface, all of you
proportional to
remember.
mass.
When the
Yes.
body is moving on the surface, understanding, mass and acceleration are inversely proportional to each other. But when the body is in free fall state, free fall, what is happening, guys? When the body is in free fall, understanding, all the objects will having a same acceleration. Are you clear?
Yes, sir.
Yes, that is how to remember. Laksha, once again, try to Manya and Samya, please. That is. Understand, everybody, Manish? Clear? That is,
Yes, sir.
remember it. So, please, all of you write the statement. I will say the statement, you write it. Just I will also will try to call them because let them join. Write the definition. Can I say?
Yes, sir.
Yes, sir.
Okay, right. All of you. Write the definition. What is the definition? Right. The acceleration produced in the freely falling bodies, the acceleration produced in the acceleration produced in the freely falling bodies. What is that, guys? Right.
Freely falling body.
Acceleration or free fall, you can write the acceleration produced. You have to remember A. Understand, acceleration produced in the freely falling bodies, freely falling bodies are free fall. Okay. Okay. Acceleration produced in the freely falling bodies are free fall. Free fall. Is it okay, Laksha? I also message. I think they joined. Okay. Right. Freely falling bodies. Freely falling bodies is the same for all the bodies. Is the what? Is the same for all the bodies. So why, guys? Why it is all the bodies is it is same? Elmokil, Tarun, Sai.
Because it is independent of mass, sir.
Because it is independent
Independent
of
of
mass.
mass,
Masses, sir.
Independent of mass. That is, you should remember. Very good. Mani and Samya, good morning. So, the acceleration produced in the freely falling bodies is the same for all the bodies. And it does not depends on the mass of the falling body. It does not depends on the falling body. Do you understand, guys? That is you should remember. Falling body. Is it okay, Pradosh? So, but when the same body is traveling on the ground, what is happening? Acceleration is inversely proportional to
Inversely proportional to mass.
Mass.
that is, you should be very clear. Okay, Laksha?
Yes, sir.
That is, but when it is freely falling, it is what? Independent of acceleration. Mass is independent of acceleration. Any doubt in this? That is, you should conclude. So, if you
No,
understand then we are going to calculate acceleration due to gravity. So as we know that G value, acceleration due to gravity, we should represent with what, guys? What we should represent?
Capital G,
Capital
sir.
G.
Capital G, sir.
Hey, acceleration due to gravity, gravitational constant is capital G. Acceleration due to gravity is represented with a
Gravity.
small g.
Small g.
Acceleration caused by
Small g.
gravity of Earth. That is why it is represented with a small g. What is to represent a small g?
Small
Let
g.
Small g.
all of you keep heading. Acceleration due to gravity. Acceleration due to gravity. Everybody. So acceleration causing by gravity. Gravity means in the sense of what? It is the word only applicable or what? Only word for gravitational force caused by what, guys?
Earth.
Earth. Gravitational
Yes, sir.
force. Understanding, Ra? Gravitational force caused by Earth. Remaining all the things we can call as what? Gravitational force only. But Earth alone we can call as
Sir.
gravity. So
Gravity.
acceleration due to gravity. Acceleration is causing by gravity of Earth. That is why you can represent with A is equals to G. What is that? G. So the symbol of acceleration due to gravity is called as small g. What is that, guys? Small g. Will you able to remember? Everybody understand?
Yes,
Ra? Now,
Sir.
what always should remember, acceleration due to gravity is small g and gravitational constant. What is gravitational constant? Gravitational constant is called as what it is? Capital G. Is it okay?
Capital G, sir.
Tamil Selvan, respond me. That is now. Let us see here. Acceleration due to gravity. Sai, try to understand. So when an object is dropped from some height, its velocity increases at what rate? Constant rate or variable rate? Its velocity is increases.
Constant rate.
Constant rate.
Constant rate.
Constant rate.
The object is dropped from some height. It will produce which acceleration? Non-uniform or uniform acceleration?
Uniform acceleration.
Uniform acceleration.
Yes or no? By whom? By whom? By the
Gravity of
Earth. By whom? By the gravitational pull of the
Gravity of
Earth. The
Earth.
gravitational pull of the Earth only. We used to call it as what? We used to call it as
Gravity.
Gravity.
that is. Try to understand very carefully. So, as we know, when the body is in free fall state, it is independent of something. What is that? It is
Masses.
Depend of masses.
of the body. Yes or no, Alana? So remember,
Sir.
acceleration due to gravity. Gravity is causing because of acceleration is causing because of Earth gravitational force. That is why we choose to represent with a small g. Understand, Ra? So as we know, when the body is in free fall state, velocity is increases at a constant rate or uniform acceleration is produced by the gravitational force of the Earth. Is it yes or no, Ra? Now, this uniform acceleration produced by freely falling body because of whom, Ra? Tamil Selvan? Because of gravitational force of the Earth.
Force of Earth.
Because of gravitational force of the Earth is only called as acceleration due to gravity. What we should call, guys?
Acceleration due to gravity.
Due to gravity.
So because of the Earth's gravity, the uniform acceleration is produced in a freely falling body. That is what we should call as acceleration due to gravity. So please allow
Gravity.
acceleration due to gravity, right? The uniform acceleration all of you write. Manya and Samya, are you writing? Sister is also there. The uniform acceleration produced in a freely falling body, produced in a freely falling body. So because of what, guys? Freely falling body. Due to what? Due to which force, Ra?
Due to gravity.
Gravitational force of
Gravitational
Earth.
force.
Sai, understand, Sai? Due to the
Yes, sir.
Gravitational force of Earth.
due to the gravitational
Gravitational force of the earth.
gravitational force of Earth is known as what we should call is known as acceleration.
Acceleration due to gravity.
Yeah, acceleration due to gravity. Mavani sir, are you there, sir? Tamil Selvan, you also. That is acceleration due to gravity. So this acceleration due to gravity is represented by what? Is represented by small g. What is that?
Small g.
Small g. That
Small
is
g.
Small g.
so you can see here the value of g does not depend on what, guys? Does not depend on the mass of the body.
Mass.
Of the object.
Body.
And you have to remember the value of g changes slightly from place to place, but for most of the purposes, we will take it as 9.8 meter per second square. Do you understand, guys? That is what you have to
Yes, sir.
so acceleration due to gravity g is equals to 9.8 meter per second square. This is
Square.
fixed value for what? For Earth, not other planet. Understand, Ra? Is it okay, guys? For Earth, the Earth
Yes, sir.
Yes, sir.
due to gravity of Earth, which is equals to 9.8 meter per second square. But now, sir, is it, you are saying that it is slightly varies across the Earth. If you are in equator, something different. If you are in poles, there's something different. So, sir, that is what is happening. What is the reason behind not variable? It is not constant, exactly 9.8. So, I will discuss you with the end of this class or else next class. So, why it is g value slightly variables, but averagely we'll take what is the g value, Ra? 9.8 meter per
9.8 meter per second
Second
square.
square.
force exerted, force of attraction exerted by what, guys? Force of attraction exerted by Earth. So when the body is coming towards the Earth, so what is happening when it is coming, keep on coming towards the Earth? The speed will increases or decreases? The rate of
Increases,
acceleration
sir.
increases. Understanding, Ra? So speed is increases for every second. That is what we should call as what, guys? What we should call speed increases. That is what we should call as uniform acceleration. Purinjicha, uniform
Yes, sir.
Sir.
acceleration. That is what you have to.
Acceleration.
So that value is equals to how much, Ramanish? That value is equals to 9.8.
9.8 meter per second square.
What do you mean by this? We can say that, sir, if suppose you ask, somebody will ask you, Earth acceleration due to gravity is 9.8. What does it mean? They will ask you. So you have to say that when an object is fall towards the ground, when an object is falls towards the what, guys? Falls towards the ground. Due to whom? Due to whom, Ra? Anybody? Due to whom? Because of
Gravity
Earth.
of Earth.
Yes or no? Due to Earth's gravity, its velocity increases at the constant rate of 9.8 meter per second. For every second of time, it is falling. Is it yes or no, guys? Do you understand what I'm saying?
Sir.
Its velocity increases what? At the constant rate of 9.8 meter per second.
Meter per second square.
Meter per second for every second of time. Do you understand, Ra? That is why it is
Sir.
called 9.8 meter per second square. So when a body is dropped freely, it falls with an acceleration of what, guys? It will falls an acceleration of how much value?
9.8 meter per second square.
Meter per second square. That is what you have to remember. If I dropped an object freely, all of you should remember. If I will drop an object freely, dropped, D-R-O-P-P-E-D, correct? D-R-O-P-E-D. Dropped means what? D-R-O-P-P-E-D. Okay. So when an object is
PP, sir.
dropped freely, what is the acceleration? Acceleration is equals to 9.8.
9.8 meter per
Meter per
second
second
square.
square.
Now, if the object is thrown upwards, upward direction from the surface of the ground, remember, so object is moving upward direction, then it is called as retardation. Understanding, Ra? Negative acceleration, which is equals to what? Minus
Minus 9.8 meter per second square.
minus indicate what? Only just opposite direction.
Opposite.
Retardation, sir.
So if it is going upward also, velocity decreases. Decreases at what rate? Decreases at rate of 9.8 meter per second square. Understand, Ra? When the acceleration is increases when the object is coming towards to the earth. When the object is going far from the earth, understanding, it will experiences a decrease in acceleration. Understand which acceleration? Uniform acceleration. Understand? That is how to remember. Any doubt in this? Please respond me. Laksha, Manya, Samaya, Maitreya. That is what. When you are dropping, when you are dropping freely, then what is happening? The acceleration will increases at a rate of 9.8 meter per second per every second. Understanding that? That is why or else uniform acceleration uniformly decreases when it is going upwards and uniformly increases when it is coming downwards. Is it okay, guys? Please respond me.
Yes,
Nobody is responding. That is what you have to remember. So when the body is coming downwards, so gravitational force also acting same direction. Yes or no? Body is also falling.
Yes, sir.
Gravitational force also same direction. That is why we can say acceleration is positive. What is that? Acceleration is
Positive.
but here the body is traveling against to gravity. So that is why acceleration equals to what? Minus 9.
9.8.
Understand, Pradosh? Manya, Samaya, at least start you have to respond. So that is, at least I will be happy. That is Alana, I hope you understand. Tamil Selvan, Maitreyan also. Is it correct, Mavanish? That is what. So that is next. If the body is moving against to earth, then the acceleration, understanding, negative. So the and force also will become what? Minus newtons will become.
Minus.
Indicate what? Minus indicate
Opposite direction.
Opposite direction.
Opposite
when
direction.
it is going upwards, the acceleration is decreases at what rate? Decreasing at 9.8.
9.8 meter per second.
But G value going against to gravity. Gravity is acting
Minus
upwards.
9.8 meter per
Upwards.
second.
That is why minus 9.8 meter per second square.
Meter per second
Is it
square.
okay, guys? That is how to remember. Understand, Ra?
Yes, sir.
So,
Yes, sir.
okay. The body is thrown. Velocity decreases or increases? Body is thrown upward. Body is thrown upward.
Velocity
Velocity
decreases.
Decreases, sir.
Velocity
Velocity
decreases.
decreases.
Yeah, decreases. When it will reaches to a certain height, velocity will become what? Zero. Understand?
Zero.
Zero.
No, sir.
Again, it will start falling downwards. So, when the body is thrown
Velocity
upwards,
decreases.
yes, when the body is thrown upwards, initial velocity is maximum. What is the final velocity? Final velocity is zero.
Zero,
Zero,
sir.
sir.
Zero.
It's free fall. Initial velocity is zero.
Initial velocity zero, sir. Final velocity maximum.
Final velocity what?
Maximum.
Maximum.
And that is how to remember this. So this is the cases. When which case this is? Calculation
Free
of
fall case.
understanding acceleration due to
Acceleration due to gravity.
that is what is that value? 9.8 meter per
9.8 meter per
Second
second
square.
square.
Let us see one more interesting actually. So the next important concept which we are going to study is calculation of. I hope you understand everything clear. Any doubt in this?
No
No, sir.
doubt.
No doubt, sir.
No. Calculation of the acceleration due to gravity. So let us go with that. Shall we start? Calculation of acceleration due to
Yes, sir.
okay. So right. Calculation.
1 second, sir.
Yeah. Calculation of acceleration due to gravity. Acceleration due to gravity. So as we know, the force exerted by the ground on the any object, freely falling object. What is the force equals to from the Newton's second law? Please respond me. From
Force is equal to mass into acceleration.
from
Force is
second
equal
law,
to
force is equals to mass into
Mass
acceleration.
into acceleration.
In the case of free fall, acceleration is equals to what? Acceleration A.
Acceleration is equal to force by mass.
Day. Bad fellow. Acceleration is equals to acceleration due
Small g.
to gravity. Understanding? Free fall case. Acceleration A is equals to what, guys? Acceleration A is equals to small g.
G.
Understanding? Ra?
Small g.
Small g means what?
Gravity.
Gravity of it.
Gravity.
Gravity. Understanding? Right? In the case of free fall. So equation will become what, guys? F is equals to m into g.
M into G.
So let me imagine that is our equation 1. That is our equation 1.